Welcome to clickmyproject.com. Now we are going to discuss about the product identification of leaf diseases in pepper plants using soft computing techniques. Now we discuss the abstract for the process. In this paper we proposes with the aid of imaging technology, the plant disease detection system automatically detect the symptoms that appears on the leaves and stems of the plant and helps in cultivating health problems in the plant and also in the farm. These systems monitor the plant such as leaf, stem and other regions and are varied observed from the characteristics features. Variations will be automatically identified and also will be informed to the user which we have undergone. This paper provides the evaluate study of the existing disease detection systems, and we have proposed the efficient detection systems by using the HSV transformation, feature extraction as well as the classification. Hence this process is well efficient to detect the affected part in the leaves as well as to classify the type of disease affected in the plant region. If the leaf is classified as an type 1 means the resultant will be produced as an type 1, hence the accuracy of the process is more and the segmentation of the leaf region is highly efficient. Now we discuss the flow diagram for the process. At first the input image is taken from the dataset. The dataset is the folder which consists of the several input images. After taking the input image from the dataset folder, the pre-processing is carried out. In this process, the pre-processing is carried by using the conversion of RGB to HSV color transformation. After converting the RGB to HSV color transformation, the HSV regions are separated as a single channel. The H region is the first band, then the S region is the second band and the V region is the third band. After extracting these three bands, the segmentation is carried out by using the masking and the threshold based. The masking is nothing but the region of leaves is carried by using the zeros and ones, and the threshold is limit from 0 to 1. The threshold limit will be like the 0.5 or 0.7 like this. By using this threshold limit, the image is converted into the binary form. The binary image consists of only two values, that is the zeros and ones. The 0 region indicates the black region and the ones region indicates the white region. After converting the image into an binary image, this is known as the segmented image. After the segmentation process, the feature extraction is carried out. In the feature extraction, we have taken the GLCM features. After extracting the GLCM features, there are 12 values corresponding for the GLCM features. That is known as the test feature. Then the classification is done. After getting the feature extraction, the classification is done by using the neural network. For this classification method, we have to give the three input. First of all, we have to give the test feature, then we have to give the train feature, then we have to give the label. The test feature indicates the feature of the input image, then the train feature represents the features of the whole dataset images, and the labels describes the plant disease. After the classification result will be displayed in the text format. Now we are going to discuss about the initial running procedure for the process. At first open the MATLAB 2013 and change the current directory. Now you can see the main_GUI.m file. If you want to execute the code means just right click in that file and click the option run. Now the initial GUI design was opened. In that you can see the several push buttons in the left side and the two axes in the right side for the display purpose. At first click the input image button After clicking the button input image, the folder was opened. In that you can see the dataset folder. Select any one image from the dataset. Now the selected image is shown in the axis 1 with the title input image. Now click the button pre-processing. After clicking the button pre-processing, the pre-processed image, that is the HSV color transformed image, is shown in the axis 2 with the title HSV image. After the HSV conversion, the RGB band is converted into the HSV bands. Now we can select the segmentation button. After the segmentation, the segmented region is shown in the axis 2 with the title segmented image. In the segmentation process, we have to take the threshold for the H region and S region as well as the V region. When taking the threshold values, the threshold value limit in the range of 0 to 1, then we have to convert the image into binary by using these threshold values. Then click the button feature extraction. After clicking the button feature extraction, the GLCM feature is applied to the image and the corresponding values for the GLCM features are shown in the table. Now click the button classification. After clicking the button classification, the identified leaf disease type is 9. Now at first I taken the input image as the 9th image, so here we have classified the identified leaf disease as 9. Thanks for watching this video.